Good morning and welcome to our panel discussion on science prioritization and partnerships. If you have questions for the speakers during this session, please enter them into the chat feature. At this time, we are pleased to welcome our moderator, Kim Hurst, Senior International Program Specialist at NASA headquarters. Kim, take it away.
Thank you, Nathan. Thank you for the introduction. I'm excited to kick off this week's ASCENDxSummit, Space Science and Technology, with today's session on science prioritization and partnerships. Scientific discovery and exploration is a global endeavor that is enabled by strong partnerships between U.S. and foreign government agencies and the commercial sector. We rely on the scientific community to identify and define key science questions through the Decadal survey process. Together, we seek to answer those important questions through innovative approaches, maximizing the scientific return per dollar. Today's panelists include Nicholas Hanowski, Head of Mission Management and Ground Segment Department at the European Space Agency; Colleen Hartman, Board Director, Aeronautics and Sciences, National Academy of Sciences, Engineering and Medicine; Tommy Sanford, Executive Director, Commercial Spaceflight Federation; and Karen St. Germain, Earth Science Division Director, NASA Headquarters. Now I'll turn it over to Colleen Hartman, who will provide a presentation on the Decadal survey, purpose and processes.
Well, unfortunately, it looks like we've lost Colleen from the broadcast, so let's move on to our next speaker.
Okay, our next speaker is Karen St. Germain, and she will discuss NASA's implementation of Decadal recommendations through partnerships.
I thought I'd just talk with you today. I don't have a chart deck because really I was hoping to follow Colleen, who would talk through, and when she comes back, she will talk through the process that the Academy goes through on our behalf to prioritize science questions and the observation capabilities that may inform them over the coming decade. So I thought I would pick up by talking about how NASA Earth Science uses partnerships throughout our end-to-end science endeavors. So first I'll talk just for a moment about what I mean when I talk about Earth science end-to-end. Of course, we start with observations, and those observations are targeted at helping us understand core science questions. That understanding gets captured in models, and when we combine the observing capability with models, that's really where we can develop predictive capability, and that predictive capability can then be used to inform decisions, and that's where we really extract the societal benefit from the Earth science. So throughout that entire value chain, NASA Earth Science uses partnerships, engages in partnerships to execute every element of that chain. So I'll talk just for a couple of minutes about how we do that. And I'll start with observations. We collaborate. There are a couple of forms that observation collaboration might take. And sorry, I'm just seeing that Colleen has re-entered. Oh, okay. So there are a couple of forms that collaboration and observations might take. One form is that we often partner with international agencies in the development of the satellite itself, and that may be collaborating on individual payloads, on integrated spacecraft, etc. One example of that is Sentinel-6 Michael Freilich, which has been a close collaboration with the European Space Agency and is set to launch this coming November. In addition, we also develop coordinated observing systems of systems, and that is to say, this is a case where NASA develops a capability, other space agencies around the world develop capabilities, and through data sharing and collaborative research that is coordinated typically through multilateral groups like the Coordination Group for Meteorological Satellites, CGMS, or the Committee on Earth Observation Satellites, CEOS, we create an entire architecture of observations that we use as a global community. A third form of collaboration on observations is with the commercial sector. To date, that has taken the form largely of data purchases and trying to exploit those commercially available data for scientific uses. And as we move forward, we think that we may be able to use Space Act agreements to find even more innovative ways to collaborate with the private sector. Then and then the next step is the research and analysis, the actual answering of the science questions. That, of course, makes use of all those observations, but in addition is built on competitively awarded, often collaborative research programs that include often internationally coordinated field campaigns, as well as global networks of surface observations and that sort of thing. The next step in the chain is applied sciences, and this is where once we have the observations and the understanding of how the Earth systems work and have models that reflect that, then we can move into providing data and information products that help decision makers. There again, NASA is a research organization. We don't want to perform other agencies' functions for them, but we want to help them perform their functions. So again, this is another kind of collaboration. For example, we collaborate through the Satellite Needs Working Group process with US agencies, and there are 6 agencies, the Homeland Security, EPA, Department of Energy, Department of Interior, Agriculture, and DOC, and within them, I'll say probably another 15 or so bureaus within those agencies that we collaborate with to extract the societal value from those from NASA Earth Science. And then in addition, we work with non-governmental organizations, for example, Conservation International, Mercy Corps, and other organizations to again take that value from NASA Earth Science and extend it globally, building capacity to use our free and open data to tackle local and regional problems. And then, so that's the value chain that I've already laid out. Of course, underpinning that, we have data analytics and information technology. There again, we are partnering both internationally and with the private sector. We have agreements in place with Google and Amazon. Have recently had agreements in place with Microsoft. Again, to enable what we call open science, which is to make the data and the information products available through, for example, Google Earth Engine or other mechanisms to improve access, to improve processing at scale, and to bring new analytic approaches to our science investigations. And then finally, the last thing I'll mention is on the technology front. There again, we have a tremendous amount of collaboration both with the private sector and with universities, for example, to demonstrate new techniques. In fact, one of our small satellites, the HARP satellite, was just awarded Small Satellite of the Year. That was a collaboration between Utah State and the University of Maryland to demonstrate new techniques. So I would say that partnerships of many sorts are infused all the way through the Earth Science program to enable us to achieve more science within the resources we have. Today, we have 7 international partnership observation systems in operations, 4 more in development, and all of our decadal survey designated observables, which I think Colleen will talk about in just a minute, include international collaboration components to them. So with that, let me hand it back over to Kim. Thanks.
Thank you, Karen, for that overview. So going back to the start, if we can have Colleen present her presentation on the Decadal survey purpose and processes.
Terrific. If I can have my slides, please. Thank you so much. There we go. It's a pleasure being here. Thank you very much, both to Kim and Karen. That was a great overview. I'm going to talk to you a little bit about what the National Academy's Decadal Service process is. But first, I'll tell you just a little bit about the National Academies itself. Next, please. So President Abraham Lincoln signed the charter of the National Academies in 1863 in the midst of the Civil War. And we have over 500 expert committees going on at any one time. And the Academies is financed via short-term study contracts and grants. That is, it runs on soft money. Next, please. I want to talk about, just for fun, the first two studies the Academies ever did. In 1863, this question was asked: can one combine the convenient decimal system of coinage with the arbitrary and irrational weights and measurements system to form a uniform system? The committee met for 3 years and found the most universal and practical system was the metric system. And in 1866, it recommended the introduction of the French system in this country. And we all know how that advice was taken. Next, please. The second study I'll mention was, again, in the midst of war, was to study iron ships and the saltwater deterioration on the bottom of ships. This 7-month study actually ultimately failed to devise an effective means for protecting the bottom of iron ships, but the fault really wasn't with the committee because the technologies weren't available. And the Navy Department actually worked on this for another 50 years to come up with paints that weren't the poisonous paints they were painting on the bottom of iron ships during the Civil War, but the report was useful. Next, please. I just want to show Explorer 1 because it's in our beautiful building, and if you haven't visited either of the buildings, please do. Of course, this is Pickering on the left from JPL, which built and operated the satellite. Van Allen is in the center. He was from the University of Iowa, and he built the instrument and, of course, discovered the radiation belts. And Von Braun is on the right. He was Army Redstone Arsenal team leader and first stage rocket manager at the time. Next, please. So what is a decadal? In 4 easy steps, decadal assesses an entire scientific space discipline. It prioritizes key science questions. It is completely based on science. And then it prioritizes the associated missions, research, facility, infrastructure, and technology surrounding those key questions. And it's important to note that this is performed by the academies independently of the sponsoring organization. Next, please. Who uses decadals? The sponsoring agencies and Congress really do use them very faithfully as a statement of priority by the science community in the United States, and they give the highest priority to missions identified in that survey whenever possible. And I think you heard that when you heard Karen discuss what is happening in earth sciences. Next, please. Here's just a montage of the space science decadal surveys over time. And you can see that astrophysics began the decadals. It in fact enabled the great observatories because the scientists queued up and were no longer fighting with each other. And then the other disciplines in space science saw that this was extremely useful for the community, and they've all followed along. So I think that's very useful to see. Next, please. So what is the philosophy behind a decadal? Science comes first. They're all science-driven. We try to engage the community as much as possible. We have solicitations for white papers, for input, for nominees and self-nominees. And we've begun a new process to really engage early career scientists in decadals with pre-decadal workshops targeted for them. And that's been, lots of people are very interested. And lastly, we try to make it transparent and open whenever possible. So of course, when committees go into deliberation, there are closed meetings in order that they undertake those deliberations independently. Next, please. The gold standard at the academies for committees, this is the process the academies undertakes these three things. First, we need an appropriate range of expertise for the task, pretty obvious. Second, there has to be a balance across many dimensions of diversity. So diversity itself is one, geographic location is one, type of institution is one. All of these things need to be considered so that these decadals are actually as represented as we can make them of the community as a whole. And the community members put on a big hat. You are not representing your discipline area or your institution. You're really thinking about the problem of each of these disciplines as a whole. And third, of course, we screen individuals for conflicts of interest. None of this has anything to do with individuals' reputations or expertise. It's just a way to make sure that decadals really have this kind of gold standard. Next, please. There are two authorization acts that cover decadals in 2005 and 2008. Now all four, and now there's 5 discipline areas with the transfer of SLPSRA, which is Space, Life, and Physical Sciences RNA Division, into the Science Mission Directorate. SLPSRA does research done in microgravity, like on the ISS and other platforms. So now all 5 have decadals, and mid-decadals are required by the authorization acts as well. Next, please. One of the important things we do in all decadals now is called TRACE, Technical Risk and Cost Estimation. And we've named it TRACE. Sometimes they called it other things in the past, but we name it TRACE because it's really centered on a technical and risk assessment. Cost is a ROM, it's a cost box that ends up coming out. It really is a risk box. So in the past, aerospace has always won this contract for our decadals. They are doing it right now for astrophysics. And it's a really important process in order to make all of the concepts on the same page. And I'll go a little more into it. Next, please. So first up, I have all of the decadal traces that were done in the past, and you can take a quick look. I hope these get posted so you can go back at your leisure and see how a lot of the large flagship mission concepts were traced in this way. But still, what does this mean? Next, please. Just in real shorthand, really, how does a trace work? Typically, it's performed above a specific cost threshold, so you're performing it certainly on flagships. And it's a way of being fair to concepts with completely different levels of development. So each concept receives a technical risk rating. And we look at historical records of past concepts and missions whenever possible, and use a Monte Carlo analysis to capture appropriate reserves and things like concept maturity, technical readiness, and that use of historical data to address likely future cost growths. Next, please. Another invention in decadals are called decision rules. And, you know, a decade is a long time. When priorities shift, there could be new discoveries, new technical capabilities. The plan might become suboptimal. So the Decadal Survey Committee writes it with decision rules that try to anticipate changes and preserve the relevance of strategic goals. The trace helps, but again, it's only a rough order of magnitude kind of an idea. So decision rules will trigger, you know, reviews, and that's really important for rescoping the science capability in ways that retains priorities. Next, please. I'll give you 2 slides of examples about this. Planetary Science Decadal, for instance, had very strong decision rules for what was then called MAC-C. It's Mars 2020, as we all know. They said if it goes over $2.5 billion, and looks like that in FY15 money, the mission should be deferred until a subsequent decade or even canceled outright. Fortunately, that did not happen, but it kind of set this expectation, and it enabled a continual review of the mission in order to keep it within scope of the other important science endeavors within the Decadal survey. Next, please. I wanted to show heliophysics, Nikki Fox's area here, as other very useful decision rules that were written into a Decadal that basically said, if you need money, here are the plus-ups that you should look to in order to pull some of the money. And in order to save time, I'm not going to go over these in detail, but I think you get the idea of how you can develop such decision rules. And of course, it's unique for each Decadal, and each discipline has different significant problems. So it's a really useful tool. Next, please. I do want to mention about how a survey is defined. We have statements of tasks that are negotiated with the academies and the agency. And when an agreement has been reached for a specific statement of task on, this is true for committee reports and for Decadals. Everything is negotiated between the, us and the sponsoring organization. But after that, the sponsoring agencies for a Decadal have no role whatsoever, not in the selection of meetings or the running of the committee. That's because it's so important that the national academies be providing independent recommendations to the agencies. Next, please. So what is report review? Report review is our process internal to the Decadal, which again is like peer review. It's independent, it's blind. We have to address every question, and the reason why this is so important is that findings absolutely must be supported by scientific evidence and arguments contained within the document. So report review helps us do that. It means it's lengthy, but it's well worth it. Next, please. So lessons learned. I just want to briefly mention the Alan Dressler report. You can find this online at the National Academies. Lessons learned from past Decadals. Clearly, mission creep is on everybody's mind. And so you do need to watch for that and look for descopes in missions before there are large negative impacts on the program as a whole. Survey committees do need to explicitly state what's needed in a flagship, and decision rules should, help people look at options to preserve against growth that would cause collateral damage. And nearly done. I just wanted to mention how the Decadals and the agencies come up with these incredibly compelling, large questions. And things across all the disciplines include, are we alone in the universe? So biosignatures on other planets is just fascinating, and really now includes every science discipline in the Science Mission Directorate. So that's a fascinating question, and you can see some of the others here. How do we improve weather and air quality forecasts? What about space weather and the interactions with Earth? That's incredibly critical. And that is not to ignore just these fundamental questions like, what is the origin and history of our own solar system? And now SMD also has hazard resources and what is available in space for human exploration. Those are new. I'm an old timer, so those are maybe 5 years old in SMD, but fascinating kinds of big questions in space science. Next, please. This is the schedule I'm showing you for the planetary Decadal. It has just started up, and the report will be released in 2022. The astrophysics Decadal report will be released next year. And so these seminal reports take a really long time. The community is incredible in how concentrated they are in these kinds of endeavors. And they produce just beautiful reports you can give your students as a survey of the field. Next, please. So what's the purpose of all of this? A balanced mission portfolio where you get the most out of your portfolio by having medium, large, and small class missions to diversify just as you would in your own investments. Next, please. And here are just a few past decadal flagship recommendations that are launched or being built, and you all know and love these. W1st is now the Nancy Roman satellite. That's terrific. Solar Probe, Parker Solar Probe. MSL is now the Curiosity rover. Europa Jupiter mission is now Europa Clipper being built. And then you can see these others. MMS, NGST is now the James Webb Space Telescope. So I'm giving you the decadal name on top and the mission name as it ended up being on the bottom. And of course, Perseverance will be the first rover caching robotic mission on Mars. So a terrific and exciting endeavor. And this is just the flagships. Obviously, again, the decadal looks at all of these different components necessary to have a robust field. Next. Thank you very much, and I look forward to questions. I'll send it back to you, Kim.
Thank you, Colleen, for that comprehensive history and overview on the decadal survey. I just want to take a moment to remind the audience that we should have a few minutes to take a few questions following the end of presentations. So feel free to submit your questions through the chat box. Our next speaker is Nicholas Hanowski, and he will provide an overview on ESA's prioritization and implementation processes.
Yeah, good morning. It's a pleasure to be able to join you. Let me just say that in my role, I'm responsible for all missions in operations at the European Space Agency for Earth observation, and that includes also the missions that we are flying on behalf of the European Union. So the Copernicus Sentinel satellites are also part of my portfolio. Let me start by recalling a little bit our mission statement here, which is to develop world-class Earth observation systems addressing scientific but also societal challenges. And I think it's important to emphasize that second element from a European perspective, and to do this in the European and the global context. And when it comes to the global context, I want to highlight that the cornerstone of that global context is our activities with NASA on the Joint Program Planning Group, which is a very active and continuous way to interact on the programmatic aspects of these large programs, with a lot of subgroups in which a lot of very practical and operationally relevant things are being discussed and implemented. That's something that is a very fixed and very important element in our calendars. Just to recall, the budget that we have available at the European Space Agency is about 1.6 billion euros per year, which is slightly more in dollars. But that's the size of the endeavor that we are pursuing. When it comes to defining elements, then next slide, please. It's important to realize that our program is divided into three fundamental lines. There is the Scientific Earth Explorer line with our Earth Explorer missions. The latest addition to this line of activities is the wind measurement mission EOLUS. Then we have the cooperative program line Copernicus, which is a joint program with the European Union in which ESA budget and European Union budgets are merged in order to finance the programmatic elements. We are just coming to the end of the first chunk of the implementations, and we are operating 7 satellites in this context and are preparing the ground to expand the fleet and the operations of the satellites in the next funding cycle of the European Union. And we have already secured by the end of last year the investments that we need on the ESA side on the scale of about 2 billion euros. And then last but not least, there's the meteorological program in which EUMETSAT in Europe is playing a very important role. We are building the satellites, but the satellites are operated by EUMETSAT, and the meteorological program definition happens actually in the EUMETSAT context. Next slide, please. Just as a background, in the preparation for our new program slides, we have actually surveyed European citizens in terms of their priority for the space program. And I think that survey is in itself a very important defining element in the program setup process. And we posed, among other things, the questions to European citizens, a considerable number. In the future, do you believe that priority should be given or not to space activities that allow us to? And then you see the various options that we provided. So to identify the effects of climate change, better understand what's happening on Earth, further the knowledge about the universe, and so on. And you can see that in the eyes of Europeans, the primary area of progression for space activities would be to foster a better understanding of what's happening on Earth, and particularly regarding the climate. And that, of course, provided a strong boost and a political backing for the program definition and the program size and comprehensiveness at the last ministerial conference, which is the defining exercise for the program, for the ESA Earth Observation Program, but also for all other ESA programs. Next slide, please. So when we come how we were actually devising an Earth observation mission, we have to differentiate a bit in what I would call a rather complex European setup. But what you see here is the essence of that setup. So to simplify a little bit, for the science missions, the Earth Explorer missions, it's the science communities in our member states that are being activated and involved. And there's a specific body in that context that we call ACEO, which stands for Advisory Committee on Earth Observation, which is the catalyst and the focal point of the inputs of the various scientific communities on assessing the value of the various proposals that we're receiving on the calls to scientific partners in our member states. So that's the specific line for the Earth Explorer line that I've shown before. The context, again, for Copernicus is a bit different because it's a joint EU-ESA program. There is a strong role for the European Union, for example, to follow and to identify their policy needs and their operational needs for the Earth observation missions in questions, but also to define and to interact with the user communities, and in particular, what we call the Copernicus services, which are the core element of the Copernicus program, which are, again, feeding back into the policy needs of the European Union. For meteorology, as I mentioned, EUMETSAT is a major defining element. And as we have a small fleet of missions that I didn't mention in the large-scale overview, I should also mention here that there is a specific program called InCube, which puts us in direct interaction with industry, which is actually challenging industry to come up with mission proposals or components of mission proposals, which then can be implemented. And some of these are quite experimental and quite challenging new elements, artificial intelligence on spacecraft, for example, and some other quite charming scenarios. So these are the four different routes that we take in order to define the process. I think the clearest and the most straightforward one and the most similar one is certainly the scientific missions on the left, where you see our direct interactions with the member states and the scientific communities in the member states. As Copernicus is not seen as a scientific program, I think I should emphasize this, but as an operational service program, the emphasis is here not so much on the science, but on the operational services. Having said this, next slide, please. This just gives you a few figures about the scale of the portfolio. You see the number of flying missions for the Earth Explorer, so the scientific program, and the future missions that we have coming up. The summary line here is high risks for great reward. So these are technologically very challenging missions. Next slide, please. And in contrast, the operational services provided by Copernicus, with huge data volumes being generated and distributed on a daily basis, and a huge user base with more than 350,000 registered users. But again, the core element, the 6 operational services that I've mentioned at the beginning of my short presentation. We are preparing the next slides. Again, let me say that Copernicus is an operational program, but next slide, please. You can see in this interesting graph that in terms of scientific impact and scientific publications, the Sentinel satellites, which are marked in green here, are now constituting a major portion of the scientific output from our Earth observation missions. So even though the missions are designed and conceived in an operational service and policy context, the output is actually scientifically quite relevant and quite important. And my final slide, thank you. Next one, yeah. Just to re-emphasize that when we talk about our Earth observation ecosystem, this not only constitutes our own missions or the missions that we're operating with our partners, the European Union and EUMETSAT, but of course also the national European missions, the commercial missions on a global scale, and last but not least, of course, the missions on which we are programmatically aligning ourselves with NASA, for example, but also in interactions with USGS, for example, in the global context. So that's hopefully a quick summary of what I would call the essence of the processes. In Europe, things are quite heterogeneous and diversified. So I think the level of complexity you can imagine is in detail quite large. But I hope this encapsulates a little bit the overall nature of the process. Thank you very much.
Thank you, Nicholas, for your presentation. You did a great job taking what is complex and making it very simple for us to understand. Finally, Tommy Sanford will provide an overview on the industry perspective on prioritization and partnerships. Tommy?
Thank you, AIAA and Kim, for hosting this panel and for inviting me to speak on this panel, Science Prioritization Partnerships. We've heard a great overview on how science is prioritized by Colleen, about how those priorities are being implemented by Karen, and how international partnerships are enabling science by Nicholas. Now I'm here to focus on how commercial can enable new missions and other ways to collect scientific data. I'm here speaking with you as part of the Commercial Spaceflight Federation, which is the leading national trade association for the commercial spaceflight industry, representing over 80 member companies and organizations across the United States. At a time when a growing number of US commercial space companies are providing cost-effective and frequent access to space for civil, commercial, and national security payloads, it is critical that NASA and the research community fully utilize these game-changing capabilities to meet its scientific mission needs. To focus in on how commercial enables new missions and other ways to collect scientific data today, I give a few examples. SpaceX has been approved to launch Category 3 missions, many of SMD's most prized and prioritized science missions, which increases the competition for launch vehicles and decreases the launch cost, and allows the science community to spend that money on improving scientific instruments and data analysis. The Falcon 9 is launching every couple weeks, which is increasing opportunities to fly missions, both primary and rideshare. For example, yesterday's Falcon 9 Starlink launch carried 3 Planet SkySats to orbit. Rocket Lab is offering dedicated launch for small sats about every month. Blue Origin and Virgin Galactic are flying suborbital payloads regularly. Over a 6-month period, they collectively flew close to 40 technology payloads at 1/16 the cost of the traditional sounding rocket approach. Planet, Spire, and Maxar have hundreds of satellites in space, which they update with new technologies and capabilities regularly, which provide for Earth and space weather observations. The Commercial Crew and Cargo program provide regular access to the ISS and ISS National Laboratory for scientific utilization of the ISS, like life and physical science experiments. Multiple providers offer redundancy, regular access, and improved capabilities that help prevent long gaps in access that plagued the Space Shuttle program and ISS prior to Commercial Crew and Cargo coming online. Commercial Crew will enable 4 astronauts to be on the station, an increase above from 3, which will improve and increase the time spent on scientific efforts significantly. And companies like NanoRack, Space Tango, and TechShot offer numerous services for the scientific community, from payload development to launching small sats out of the ISS. Those are just some of today's opportunities. There are a number of upcoming opportunities for the space community as well. For example, human-tended research opportunities on suborbital missions and the ISS. NASA's Flight Opportunities proposal is offering to fund human-tended research flights on commercial reusable suborbital vehicles. And NASA is working through now to enable private astronaut missions like private researchers to the International Space Station. NASA's small-sat planetary missions, CLIPS, Gateway cargo resupply missions, and human lander system programs will offer unprecedented regular access to the lunar orbit and the lunar surface for researchers. While the commercial space industry has been working on these capabilities for many years, I want to take a moment to note and thank the NASA Administrator, Jim Bridenstine, and his amazing leadership team at NASA, including Thomas Zurbuchen, that have enabled and accelerated these opportunities becoming available to the scientific and research community. NASA has done a great job increasing the commercial partnership opportunities for the scientific community. And just to name a few of those, I'll give a few examples. Modernizing NASA's planetary protection policies, ensuring the ISS National Laboratory can fully enable scientific opportunities, flying human-tended research on commercial reusable suborbital vehicles, flying scientific payloads on free flyer missions, enabling researchers to work on the station as private astronaut missions, fly payloads to the moon via small-sat planetary missions, CLIPS, Gateway and Gateway cargo resupply services, and commercial human lander systems to the lunar orbit and lunar surface. Increased access and utilization of commercial Earth data, science data, and increased flight opportunities through reusable launch opportunities and dedicated small-sat launch missions. Some additional efforts still need improvements, for example, evening the playing field for ROSA's suborbital missions, but overall, Administrator Bridenstine and his leadership team have done an amazing job. So I'd like to conclude my remarks with only a few minutes left, and I appreciate you including CSF in this important discussion, and I'm happy to answer any questions you may have.
Thank you, Tommy. I just want to thank everyone for their patience as we work through the technical issues this morning. I think we only have time for a couple questions, so I will jump right into the questions. First one is, what is the best way for interested members of the space community to get involved in the Decadal survey process? So Colleen, I think you are best suited to answer that.
This is a terrific question. I just want to really encourage people to participate, and there are a lot of ways to do so. First, when a decadal starts, you can self-nominate. You can nominate yourself. You can nominate others you think would be terrific on the panel. You can also nominate chairs or chairs for the panel. So please do that. We also then take white papers on science, white papers on potential missions, white papers on state of the profession and what's going on with diversity and inclusion. And you can send those in. These are all very short. It's only, half a dozen pages or so. You can participate in the early career events. We've had 3 for planetary. They're all on the website, taped, if you would like to take a look. And then you can listen to open meetings held by the Decadal. And those 2 are publicized on our site. And one last thing I'll mention is that the discipline committees we have for the Space Studies Board in each of these areas have meetings. Please attend. Now that they're virtual, there's no problem. It's like Hollywood Squares. Just come on and see what folks are talking about and get educated about what's coming next. So really, I very much encourage everyone who has an interest to participate. And thanks again for the question.
Thank you, Colleen. So we have one more question that I think we'll have time to answer. Is there an attempt to map the science goals from the Decadal survey onto applications, for an example, projects, systems, mission capabilities? The person asking the question is thinking in terms of applications such as radiation protection of humans in space, cryofuel transfer in space, or self-healing materials for space systems. I don't know if anyone wants to volunteer to answer that question. I think some of these topics will be covered in the later sessions this afternoon and the rest of this week.
So I can mention that technology is covered in the scope of decadals, but I think perhaps NASA can answer this. Maybe either Karen or Nicholas could say about for instance how new technology gets embedded.
So this is Karen. This is a little bit different use of applications, of the word applications, than we use in NASA Earth Science. But I will say that for the designated observables that come out of the Earth Science decadal, we do actually embed applications-focused team members into the study team that is looking at the options for implementing that designated observable. So we do try to build applications right in up front as we're building an observation program. And again, our applications are a little bit different from the ones that are specifically requested here. But in terms of technology, we also do have the decadal influencing our technology investment program, which is our seed corn for the future observations, the things that we maybe can't do right now, but by the time we go to our next decadal, we want to be able to do. So there's a lot of influence there on our technology investments. I'll stop there. Thanks.
Thank you, Karen. And I just want to thank everyone on today's session. We have a hard cutoff, so thank you for joining in the session today on science prioritization and partnerships.
Thank you.
Thank you all for joining us, and thank you for joining our panel discussion on science prioritization and partnerships. Up next, we're going to hear updates from NASA programs that provide opportunities to deliver payloads to space in space-relevant environments. That's starting at 11:45 Eastern Time, so please stay tuned. Thank you very much.